Hello. Let's take a look at how we can write expressions to represent each of the following sketches. And then we're going to try to give the value of each sketch. So for letter A, I go ahead and I count how many positive symbols we have in here, or plus signs. 1, 2, 3, 4, 5. So I would start by writing 5 plus, and then I've got 3 negatives, and that gives me 2. One way I like to think about these is when I can put together a positive and a negative symbol, they equal 0. The next thing that I'm going to take a look at is the problem that has the number line. In the number line, we look at where we typically start with our numbers. And this one, if I am at 0 and I go to 4, and then I go backwards some distance, I end up on -2. And if I count this, 1, 2, 3, 4, 5, 6, I went back -6. So 4 plus -6 is equal to -2. Moving on to this next one, I count up my symbols. It doesn't matter which ones I put first. So today, this one I'll go ahead and do the negative symbols. 1, 2, 3, 4. -4 plus 1, 2, 3, 4. And that equals 0 because we've learned that opposites of each other, when they're added together, equal 0. And this problem, again, I'm taking a look to see where 0 is, and I went to the left to -4. Let's start with -4 plus something, and I land on, or I end at 3. A lot of us could take an educated guess and be accurate and precise and right on with that answer, but I'm going to go ahead and show you how I'd use a number line. So I would count 1, 2, 3, 4, 5, 6, 7. -4 plus 7 equals 3. All right, down here at the bottom, it says that we are going to use these numbers and the operations of addition, subtraction, multiplication, and or division to create 3 different number expressions with 3 different values. One of them should have a value of 37. Well, let's start with that one. 5 times 6 plus 7 equals 37. I do not need to put parentheses in here because I know that I would work the multiplication first because of order of operations. If you want to put parentheses in, we can do that. Another problem that I can use, or that I can make, is 5 plus 6 plus 7, and that equals 18. Do not need to group any of these. And then I would like to mix these up again. Let's do 7 times 6 plus 5. And again, you do not need parentheses, but we'll put those in just for fun. 7 times 6 is 42, plus 5 is 47. 3 different expressions, 3 different values. You might have gotten different ones than I did, but hopefully everybody was successful in getting the answer of 37. Moving on, I'm going to be writing these fractions as decimals and decide if they are terminating or repeating. For this first one, I know some of us have a little bit of trouble deciding what number goes inside the division box. And if I'm doing 7 divided by 8, just like the fraction at 7/8, 7 divided by 8. And I know that looks weird, but the numerator is in the top part of our fraction. It comes first when we write it or read it as a division problem. 8 does not go into 7, so I'm going to go ahead and I'm going to change this into a decimal by thinking how many times does 8 go into 70? And I know that's 8. I do my math, and I end up with 6. Bring down another 0. 8 goes into 60 7 times because 8 times 7 is 56. Do my math work there. And looks like one more time. And I know that some of us like to see those zeros drawn down with arrows. 40, and I get 0. So I'm going to go ahead, and 8 times 5 is what I really did. So I know that many of you do not like to show your work like this, and I'm going to do the next one with a calculator. And here's my calculator. Scooch this all around a little bit. And I'm going to input the number 2. Let's tip this up so we can see it a little bit better. 2 divided by 9 equals a repeating decimal. We learned in one of our lessons this week that when 9 is in the denominator, it's one amazingly huge clue that we're going to get a repeating decimal. So this problem would be written 2 divided by 9, and that equals 2/10 repeating. The next problem I have is 4 divided by 7. And in order to do this, I again remember that my numerator goes in the division box. 7 goes into 40 5 times, and that's 35. Subtract, and we get 5 brought down. Make sure I put my decimal up there so I don't forget it. 0, bring another 0 down. 7 goes into 50 7 times. 7 times 7 is 49. Subtract, and we get a 1. Bring another 0 down. And we have 7 goes into 10 one time. And we do some subtracting. Bring down another 0. 7 goes into 30 4 times. 28. Do some math. And I'm going to bring down another 0, extend my equal sign there. And 7 goes into that 2 times. And if we take a look at this, see what happens. Bring another 0 down. 7 goes into 68 times. Do some subtraction. And I end up with 7 goes into that 5 times, and we are repeating. This time, though, our repeating, we take a look, we have our 40 up here and our 5, and we also have a 40 down here, and we have a 5. So we're starting to repeat again. Sometimes repeating decimals have just one number that we have the repeating bar over, like we had in the previous problem. Sometimes the repeating bar needs to go over a bunch of the numbers in the decimal places. I know some of you are wondering, did she do that math right? And I'm going to double check it right now. All right. So that is what I get when I do 4 divided by 7 in the calculator. And you'll see that we had the beginning of our start of our repeat at the end of my decimal places here. And then we'll go ahead, and since we are running out of space here, let's go ahead and we will, now that the calculator is clear, we'll do 11 divided by 22, and we get 5/10. So this would be 11 divided by 22 equals, and there we go. We got this.